Hello, ladies and gentlemen. Welcome back. We are on chapter 10.3, confidence intervals with proportions. Just letting you know, this is my third take. I thought I was almost done. I had over 20 minutes of video going and I realized I made a big goof. So I am redoing this video. So I hope you appreciate this. All right. Hopefully I won't make any mistakes this time. All right. So we are doing confidence intervals with proportions. So P hat, remember, stands for our sample proportion. So what is P hat? The number of successes in the sample divided by the number of individuals in the sample. All right. A brief overview of important properties. Now you can print this, ladies and gentlemen. This is right above the video if you want to just print this. Center. The mean P, that is the sample proportion P hat, is an unbiased estimator of the population proportion P. Remember, it is not realistic to know what the population proportion is, but our sample proportion P hat should be an unbiased estimator of that P. The spread, the variability. The standard deviation of P hat is the square root of P times its complement divided by N, provided that the population is at least 10 times as large as the sample. Okay, that's rule of thumb number one, but don't use the words rule of thumb number one. Please describe why the spread, or talk about the spread with at least 10 times the sample. Okay, the population. Shape. If the sample size is large enough, then the N times P and N times its complement are at least 10. The distribution of P hat is approximately normal. Okay, rule of thumb number two. Now, in practice, of course, we don't know the value of P. Okay, it is not realistic. If we did, we wouldn't need to construct a confidence interval for it. So we cannot check whether N times P and N times its complement are greater, 10 or greater. In large samples, P hat will be close to P. Therefore, we replace P with P hat in determining the values of N times P and N times 1 minus P. We also replace the standard deviation by the standard error of P hat. Okay, so notice, ladies and gentlemen, we will be using P hat inside that. To get the confidence interval, we use the estimate times the critical value times the standard error. Okay, and remember, the Z star times the standard error is our margin of error. Let me just quickly pull up, ladies and gentlemen, the formula chart. So again, right here is our confidence interval. We've got our statistic plus or minus the critical value, times the standard deviation of the statistic. Now, before I go any further, I do want to go back to the flow chart. Again, mine is kind of sloppy. Maybe you can make yours look a little bit better. So we've got the confidence intervals. If we're dealing with means, averages, okay, we go to the left. And then if we know the standard deviation, okay, we then use this formula, X bar plus or minus Z star times the standard deviation divided by the square root of N. Okay, but that's not realistic, is it? So if we don't know the standard deviation, then we use the T distribution, X bar plus or minus T star times S divided by the square root of N. And we use our degrees of freedom, and we use, I'm going to add this, and we're going to be using table B when we find that. And we have to check our conditions, right? Okay. Now, we're dealing with proportions, ladies and gentlemen. So we go to the right. So it's going to be P hat plus or minus Z star. Proportions will always use Z star times P hat times its complement divided by N. And those are the conditions, the simple random sample, and those two rules of thumb. Okay, but we'll go into detail in that in a little bit more in a few minutes. All right, let's get back to the notes. So again, here are our conditions, ladies and gentlemen. You can pause and copy those down if you want, or just go ahead and print this off and have those handy in your notes. Here's our simple random sample. Checking for normality, we need N times P hat and N times its complement to be 10 or more. That's normality. Independence, that's where we need to take the sample size needs to be or the population needs to be at least 10 times as large as the sample for independence. All right, let's keep going here, ladies and gentlemen. So again, here's our formula that I just showed you on the flow chart. All right, and we're going to look at an example here shortly. I do want to point out, ladies and gentlemen, there's an excellent example, another example to look at on page 670. Please look at that example and the details. Okay, but before I do that, I do have a little problem that I want to go through, a PowerPoint that I got from the instructor when I went to training a few summers ago. Okay, here it is. Okay, it's a little silly thing, but it's kind of fun to see and have a little fun with it. All right, the confidence interval for a population proportion. Okay, looks like we got the tooth fairy going on here, folks. So again, step 0, make sure you understand the problem. So this is the problem, okay? The lives of young children, including many figures, some real and some slightly less so. Among those slightly less so are monsters in the closet and fantasy figures such as Santa Claus, the Easter Bunny, and the Tooth Fairy, okay? Now, investigators were interested in the strength and duration of such beliefs, specifically in the ages at which beliefs in such fantasy figures decline. Okay, now I do realize this is different for each culture. Okay, they have different things going on. Okay, so bear with me here. The investigators interviewed white, middle-class Christian children in southern Michigan. Okay, so they very narrow it what they investigated or who they interviewed, and categorized them as either firm believers or not firm believers in various fantasy figures. The data for belief in the Tooth Fairy is presented in Table 1. Okay, there it is. So we've got 29 6 to 7-year-olds that are firm believers in the Tooth Fairy and 21 that are not. Okay, that makes 50 that they interviewed. 8 to 10-year-olds, 12 and 35. Okay, we're not interested in 8 to 10. We're going to look at the 6 to 7-year-olds. So identification, the statistic, the confidence level, estimate the sample distribution. So we're going to use a 95% confidence interval, which means we're going to use p hat plus or minus. Now remember, z star, so let's go to the table, table B, okay, down at the bottom. We're doing a 95% confidence interval, so the z star is 1.96. And again, with proportions, ladies and gentlemen, we always use z star. We will never use t star and degrees of freedom with proportions. All right, oops, wrong one. Let's get back to this one. All right, so that's the formula we're going to use. Remember, you do have to identify that. Step 2, we're going to assess the credibility of the sample distribution. Okay. So we took our 29 divided by 50. We got our p hat. We took n times p hat. That's 29. N times its complement. That's 21. Well, ladies and gentlemen, since they are both greater than or equal to 10, the use of the large sample confidence interval for a population proportion is reasonable. Okay, we are good to go on that. Here's just a little graph showing this just department graph gratification through verification. So he just did a little histogram here showing how very normal it actually is. Okay, don't worry about that. The mechanics, folks. So this is where step 3, we got to plug those numbers into our formula and come up with our confidence interval. And remember, the 1.96 times the standard deviation, that is our margin of error. So we add and subtract it from the 0.58 and we get this confidence interval. And again, step 4, the interpretation and context. Be really, really careful. Okay, now again, remember the difference between the confidence interval and the confidence level. Okay, the interval will be the first one, the level will be the second one. And we saw this when we did the means also. So I am 95% confident that the true proportion of 6 to 7-year-olds to have a firm belief in the tooth fairy is between 0.443 and 0.017. That's our confidence interval. Our level, the confidence level of 95% refers to the fact that in repeated sampling, intervals constructed in this way will include the true proportion, population proportion 95% of the time. Okay, let us go ahead and do our own here, ladies and gentlemen. Again, pause. I know I'm going really fast. I'm trying to keep this video as short as possible. So pause if you need to. So this is going to be our task, ladies and gentlemen. Here is our problem. We have a random sample of 1,100 teenagers, 12 to 17, that were asked whether they played games online. 775 said that they did. Okay, that proportion is probably much higher nowadays because this was done over 10 years ago. We are going to construct a 99% confidence interval for the population proportion. Follow the inference toolbox. All right, remember step one is we're going to state what we are interested in doing. So let me get my thing set up here. Here we go. So the population of interest is the proportion of all teenagers who play games online. Now we probably should put in ages 12 to 17 in that also. So that is step one. Step two, simple random sample. Well, ladies and gentlemen, it is stated that it is a simple random sample, okay, in the problem. So you need to actually write that. It is stated within the problem, random sample of 1,100 teenagers. Okay, you have to write these out. This is our formal steps before we get to a conclusion. Okay, normality. Well, normality, this is where we got to do a little bit of math. Okay, so normality, this is where we take the 1,100 times the proportion. Well, I didn't do that yet, did I? So let's go ahead and find our p hat, ladies and gentlemen. So our p hat is going to be 775 divided by the 1,100 teenagers. And that's going to be 0.705. So we're going to take 1,100 times the 0.075, and we are going to get 775.5. Now that is greater than or equal to 10. And we're going to take the 1,100 times its complement, which is going to give us 324.5, which is also greater than or equal to 10. Well, ladies and gentlemen, since both are greater than or equal to 10, we can safely say it is approximately normal. Normality is good. Independence. We assume that there are at least, okay, that's 11,000, folks, 10 times 1,100. There are at least 11,000 teenagers who play video games online, okay? Definitely there's more than 11,000 teenagers who play online. Okay, so here comes our calculations. So again, we need to go ahead and put down our formula. So p hat plus or minus z star times the square root of p hat times 1 minus p hat divided by n. Okay, we plug our numbers in. 0.705 plus or minus. Okay, this is where I goofed in the last video. Okay, we're doing a 99 that you don't see because I'm shooting a whole new video. We are doing a 99% confidence interval, so we got to go to the 99%, which is 2.576. All right, so 2.576 times the square root of 0.705 times its complement. Well, ladies and gentlemen, its complement is 0.9295 divided by the 1,100. Okay, so now, ladies and gentlemen, I'm going to go ahead and find the margin of error. Okay, to find the margin of error, I'm going to take the 2.576 and I'm going to multiply that to the square root of the 0.705 times, notice I am not using parentheses inside, I'm just going to use the times sign. And please make note that the square root is still, all of that is still under the square root. If you are using an older calculator, you need to put parentheses around it. Okay, and so here's my margin of error, ladies and gentlemen, 0.0354. 0.0354. And now I can go ahead and come up with my interval. Okay, so now I'm going to go ahead and I'm going to take my 0.705 and I'm going to take away 0.0354 and we're going to get 0.6696. And now we're going to take and we're going to add, 0.705 plus the 0.0354, and we're going to get 0.7404. Voila, I have my calculations. Now, in the next video, I'm going to show you how we can we still have to be able to plug our numbers in. We got to identify the formula, we got to plug the numbers in, but then after that, we can use a little shortcut on the calculator. Okay, instead of doing all of this, I'm going to have the calculator give me the interval immediately. Okay, but I'm going to show that in the next video, so please watch it. All right, so ladies and gentlemen, we can say with 99% confidence that the true proportion of teenagers 12 to 17 who play games online is between 0.67 and 0.74. Boom, we're done. Okay, what else do we need to be able to do? Well, ladies and gentlemen, you have to also be able to find how large of a sample you need if you have a certain margin of error that you want. All right, so here is our formula. Now I'm going to rewrite that and get the n by itself again. But before we do that, there's something really, really important you need to know with this, with proportions. Okay, right here. Here, Z star is the critical value. Okay, well, we already know that for the confidence interval we want. Because the margin of error involves the sample proportion of p hat, we need to guess this value when choosing n. Call it p star. Now, ladies and gentlemen, there's two conditions here. One, you can guess p star based on a pilot study or on past experience with similar studies. We're not going to do that. We are not going to do that. We're going to stick with number two. We're simply going to use p star as 0.5 as our guess. The margin of error is largest when that is 0.5. So we're going to get a very conservative sample size. It's probably bigger than what we actually need. Okay, so we're just going to go ahead and use the 0.5 because that's going to give us it's going to give us our biggest sample size that we need for that margin of error. Okay. All right, so here's our formula, but again, I don't like that. I'm going to take and I'm going to do some algebra to that, and I'm going to rewrite it so that n is by itself. Okay, I'm going to do that below before we actually, and there's another example of this on page 672. Please look at it. So before we do this, for the last problem, folks, I'm going to go ahead and take this and I'm going to do the little algebra and get n by itself. So the margin of error is going to equal the z star times the square root. Now I'm going to put p star there because I'm going to use 0.5 in its place, times its complement, divided by n. All right, so the algebra here to get n by itself, we're going to square both sides to get rid of the square root. So we now have m squared equals z star squared, because that's not in the square root, folks. The square and the square root cancel each other, so times p star times its complement, divided by n. Now, ladies and gentlemen, I do my little algebra here. Basically, what I'm going to do, folks, is I'm going to swap the n and the m squared. I'm going to multiply both sides by n, and I'm going to divide both sides by m squared. So I end up with the sample size equals z star squared times P star times 1 minus P star divided by the margin of error squared. Okay, now based on the last example, so I'm up here now, folks, based on the last example, how large a sample would you need to take an estimate within 2% at 99% confidence interval? Well, remember, ladies and gentlemen, your margin of error is 2%, but we always change that to a decimal. So we got to use 0.02. All right, so I'm going to plug my numbers in now. So the sample size is going to equal, now 99%, ladies and gentlemen, remember 99% is 2.576. So I'm going to take 2.576 squared times 0.5 times 0.5 divided by the 0.02 squared. Now I'm going to trust, ladies and gentlemen, that you can type that into your calculator on your own. So I'm not going to bother showing it to you. Please practice it. You should get 4147.36. But remember, we always round up. So we're going to say 4,148 teenagers. So to be within 2 percentage points we're going to need a sample size of 4,148 teenagers. All right, ladies and gentlemen, so that is video number 1. I'm going to do another video, okay? Please watch it. I'm going to show you, I'm going to do a problem that I would do for a warm-up if we were in class. It's from 2010. It's an AP question dealing with proportions. So I'm going to do that first. And then, ladies and gentlemen, I'm going to show you the problem we just did. Okay, let me go back. I'm going to show you how we can just put the information into the calculator and have it spit out the interval really quickly. Okay, so I'll show you where those buttons are on the calculator, which you kind of know where they are already from chapter 10.2. All right, ladies and gentlemen, I will see you in the next video.